I would like to tell you about a technology that that's already been mentioned a couple of times, and that is Shiny. Right? How many of you have worked with Shiny? So worked with Shiny. So maybe 1/5 of the audience have worked with Shiny. So I will spend most of my talk talking about Shiny. I'm not affiliated with Shiny in any commercial way. But I think that Shiny is a fundamentally very powerful tool that is gradually changing the way people think about data science, about the way we as data scientists work with data. Shiny is not the only solution out there that does this for you, but Shiny is probably the most developed one that's available right now. Now, before I go there, I should mention that I work at a wonderful company called Uptake. We have a large team of data scientists, and we are always looking for talented people to join us. If you are interested in industrial IoT, Internet of Things sensors, I'm happy to answer questions. And we also have Zach here, who is a great fan of the Chicago Cubs, who is also able to answer questions about Uptake. So let me go back to the beginning. So the beginning is this. We would like to get value out of data. We would like to get as much value out of data as possible. We have a limited amount of data. We have a limited amount of time. And we as data scientists, we must deliver value. Data is hard to collect. Time is limited. Time is not available. And we always must find the best way of getting the most out of that limited amount of data. Potentially, data can give us some kind of insights, maybe give us some kind of presentation we can deliver. We can test a hypothesis, or sometimes we can get a product out of data. So what is the best way of the most value we can get from a finite amount of data? There is what exists right now, or existed before toolkits like Shiny. Essentially, there are two pathways we can take data. Pathway 2A, which I call 2A, is to write a report. So we have built our model, we have analyzed the data, and we could write a report. We could write a peer-reviewed report. We could get published in Nature or Science. The other way that it happens infrequently, especially infrequently in academia, is actually to collaborate with software engineers, build a UI, pipelines, databases, and create some kind of a data product. Those of us who started in academia tend to follow pathway 2A. They write a report of some sort of peer-reviewed publication. Those of us who are in industry may have more access to developers, software engineers, and then we will build some kind of a pipeline. That's a very capital intensive, that's a very capital labor intensive, resource intensive pathway 2B. So in academia, that rarely happens. It actually infrequently, even in the industry, that happens quite infrequently because all this resources needs to be justified in some way. And typically, there's a lot more questions that we can answer, and we don't really have those resources, all the software engineers, to help us data scientists get that value out of data. So now there is a new pathway. That is a pathway which I'm going to call productization toolkits. So 2C is what my talk is all about. 2C is it's a smaller evolution. 2C, those productization toolkits, give you, the data scientist, a way of creating a product. You don't need any software engineers. You don't need any UI experts. You don't need to know JavaScript. You don't need to know all the stuff that you have never learned to know. You can build a real product by yourself. You can even create a startup company from a database. That is very, very powerful. So I think that my message here is that we really need to think and invest time mastering and then using those tools. Tools like Shiny, probably the most important ones, but also related technologies. For example, Tableau is another solution. There's Rook, Spire, Flash that do aspects of this. That is the number one most important slide. I think that there's an incredible amount of value that could be done by a single data scientist with a productization toolkit. You can create a product out of data right now. It will take you, if you know Shiny, and you have a model, you can create a product in 1 day. That has never existed before. If you're considering writing a paper about a data set, why not build a product out of a data set? Why not build something that's much, much more valuable to many more people that's going to be alive? So the rest of my talk is all going to be about an example of a project that we recently did, a project that actually started by one of my students. He did this in 1 month. Now that I know how to do this, it will take a day or a couple of days to do what he did in 1 month. And this has not been possible before. So the outline of my talk is the following. I'll give you a little bit of a background on diseases in Latin America and the problem we want to solve there. And then I'll tell you about RShiny, what does Shiny do, how does it look like, and I'll then finally describe the solution we developed. This solution has essentially, the alpha version of the solution has been finished in 1 month's work. This is a solution that I would say has really been transforming some of the disease work that's happening in Peru, and it really has only taken 1 month to reach the alpha stage. So let me take you now to a public health problem. How is my sound? Can you guys hear me? Can you still hear? Yeah. So there's something called triatomine bugs, and here's how they look like. They are not found thankfully, they're not found in North America, but they're all over Central America and Latin America. And this is a triatomine infestans, also known as a kissing bug. It's pretty large, so it can go about 1 inch long. So it's a very large bed bug. And like a bed bug, it feeds on blood. And it's very problematic because it actually spreads diseases like Chagas disease. There is a hypothesis that Charles Darwin actually died because he was bitten by triatomine. He had this famous voyage of the Beagle, which led to the theory of evolution, and he was bitten and had some kind of a disease, we don't know exactly what, that will stay with him for the rest of his life. And that disease might have been Chagas disease, one of the diseases transmitted by a triatomine bug. The work that I've done was in a place called Arequipa in Peru. It's about here. And you can see here that's one of the areas that has this triatomine infestations in Peru. So what we wanted to do is the following. We wanted to take an existing model and make it into a tool. The research team there have collected a lot of data that allows them to predict which houses might have those bugs. And here's a city map. All the streets have been erased, so it's hard to say which actual houses. You cannot tell which actual houses has infestation. But if you have a model that says that this particular house has a high probability of being infested. And for example, we know that if a house has animals in there, then the bugs can feed on the animals, and it's more likely that it's going to have bugs. We have other information like the construction type. So there's an existing model that was developed, and that model is completely useless because that model sits in a paper, and it's really hard to make this paper actionable. There's no product around that paper. Right. So what we wanted to build an app where people could just pull out their cell phone, go out in the field, stand next to a house, and then say, this house is a red house. I'm going to knock on the door, and I'm going to see if this house has bugs. So before, what was happening was this. People would just have to go around every city, knock on everybody's doors, and figure out if this house has bugs or not. The model can actually tell us that there's a hotspot of bugs right here, whereas here there's few bugs. Make sense? So we wanted to build an app based on the existing model, a bag that allows us to give us some tracking ability, visualize the city, and everything like that. Now, before Shiny existed, this would have taken us, a good UI developer with JavaScript knowledge, with a lot of work, and a lot of money, and a lot of time. But it's a pretty trivial problem for Shiny. So I will now tell you a little bit about what Shiny does. Shiny is an R package developed by the people who brought you RStudio. How many of you use RStudio? Yeah. So RStudio is probably the dominant platform for using R. It's an IDE for using for R. Now, Shiny is basically a package for R. The folks at RStudio give you also a cloud platform called shinyapps.io. It's a cloud platform where you could basically put your models. Their basic level of service is free. So if you have a model in R, you can actually put it on the cloud, and people from anywhere can access it, play with it, look at your data, look at your model, look at the model outputs. You don't have to expose your data. So with shinyapps.io, you can basically productivize models, put them on the cloud for free. Now, Shiny itself has two parts, the server part and the UI part. I will show you a little bit how it looks like shortly. And it has two variables, an input type variable and an output type variable. So the way it works is the following. Input type variables are variables that are displayed in the UI, and output type variables are stuff that your model changes. It's something that contains an output from a model, maybe a graph, maybe some kind of a number. The app itself is an event-driven application. So what I mean is, if the user does something in the UI, like types in a number, then this is sent to the server.r, and then your model sees a new input. And then the model can recalculate something. And once the model recalculates, it updates the output variable, and then the UI changes. And that's how it works. So here's one of the demo apps. I'm one of those people who study irises, like the rest of the presenters here. This is the iris dataset again. And this is a very simple example of a Shiny app. What this app does is this. You select two variables, the app visualizes them, and runs clustering. So you can see here that the two variables are petal length and petal width, and we wanted to cluster them into 3 clusters using the k-means algorithm. The visualization there has been generated, and you can see here that there's a red cluster, blue cluster, and a green cluster. Now, without having Shiny, I don't think I would have been able to do anything like that. And a software developer knowing JavaScript probably would have taken maybe a week to build something like this. Now, here's the code for this using the Shiny package. This is all the code that it takes to build this. Let's first look at the UI, UI.r on the left. So this code actually has a little bit of a tree-like structure, and it's not an accident. This code has a tree-like structure because it actually immediately generates HTML and it generates JavaScript. And XML has a tree-like structure. So what it says is you're going to build a page. It has a panel. It has a sidebar panel, and it has 3 input variables: select input, and numeric input. You cannot see my pointer. So this function basically adds an input where you could select from a list of names. Again, select from a list of names, and you're going to call this variable xcall, and this one variable is going to be called ycall. And there's going to be a numeric input, which is going to be called clusters. And it's going to have a default value of 3 with a minimum of 1 and a maximum of 9. Finally, there's going to be a main panel, which is going to be displaying a variable called plot1. This is the UI. The server is a single function here. There's some magic here. So the magic is this mess called reactive, which I'm not going to go into. But this magic allows the two parts to communicate. So what you're going to have is you're going to have some R environment doing calculations and interacting with a web browser. So that requires some magic. But everything else is pure R. So we have the iris dataset right here. We are going to select part of the dataset that has the X column and it has the Y column. And then we're going to call k-means, the function k-means. And it will tell it that we want input dollar clusters, so 3 clusters. It's going to go into this variable called clusters. And then we're going to render a plot using standard R-type rendering. We're going to call the plot function. We're going to put points on it. We're going to color them. And we're just going to deposit it into an output dollar plot1. And output plot.1 is going to be sent into the UI.R. It's going to land here, become JavaScript, and show up. So this is pretty easy. This is really awesome. This is productivation. Your model is sitting in this line right here, k-means. Whatever model you want to show, you can just put it there, and it's going to be displayed. The output is going to be displayed for the entire world. For anybody who wants to connect, you'll put some security on it to protect it. But this is the productivization of model in a single page. This is awesome. So the way we work with this is the following: we run the IDE RStudio on our desktop for testing. We can put it on our server. Let's say we can spin up a server, and then client devices connect to the server using their web browsers, or we could go to Shiny Apps Cloud and then have our model sit on the cloud. There's a basic tier of servers which I think allows you 5 hours of uptime, which is completely free. And you can pay more money, and then you have more time of calculation time. Now, to do that, for the Peru project, we did some mapping, and there is a nice library called Leaflet that's well integrated with Shiny. It uses OpenStreetMap data, and it has bindings to R and Python. R is the more important one. So this is a nice add-on that allows us to visualize mapping data. Here's the final product that we have built. So we call it the vector point. Vector because their bug is a vector. So people go on this page with their smartphones, and they have to type in identification information. Once they pass the identification page, once they get authorized to go in, they see a map. The streets you see the city streets, you see the houses. This is the input from a model, and you can see the colors indicating which places have hotspots of infestation, like this area, and people are using this every day out in Peru. This very simple app. They go up to those houses and we start inspecting them. We collect this data on a cloud database. I'll tell you a little bit more, and then we can update the calculations. We can rerun the model, put the data back in the database, and visualize new results. They can also enter inspection data. So what they can do with this app is they can actually click on the house and get a pop-up. You can see here a little pop-up here. They can click on the house. The information has been anonymized deliberately. And then they can say, I would like to inspect this house. And then they have information a place where they can enter more information about this app. They can say, I have found some bugs here. I have not found some bugs. I've talked to the people there. All of this data then is recorded. Behind the scenes in Vector Point, in our tool, what we've put in, we've done Amazon Web Services, AWS, RDS database that collects all the results from inspections. and we are using the Shiny Apps cloud platform. We are using the desktop right now to do some to run the model itself, and then we upload the model results to the database, and it's visualized and pulled by the app, like you point out. So let me kind of go back to the bigger theme. What does productization allow you to do? You can basically build a product out of a model, and that's awesome. To build this one took us 1 month. Knowing now what I know about this technology, I think it shouldn't really take more than a week to build an equivalent app. That's pretty awesome. This is pretty awesome for the technology. This is a successful tool. It's much more than a paper publication, and it's pretty easy to maintain. There is definitely challenges with RShiny. First of all, it is very, very strongly interwoven with R. So you can only use this particular package if you have a mastery of R. There are certainly equivalent packages or something similar in Python, but I would argue that the Shiny package is probably the best productization package I'm aware of. Another problem with Shiny is that it relies on JavaScript. JavaScript throughout. JavaScript is mostly invisible until it breaks, until something is not working the way it's supposed to be. So this is something that might happen and might require you to understand JavaScript. That's inevitable. And when that happens, you'll have to start entangling R and JavaScript. And I think that's probably inevitable because the web requires JavaScript. There is certain fundamental limitation of Shiny. First of all, Shiny has a single-minded task of making productivizing models, putting your R code online on the cloud, making it accessible as a product. Secondly, the client line, it's not a mobile app. Shiny stops working as soon as internet connectivity is lost. This is something that had a significant effect on us in Peru because there are parts of the city that's really hilly and there's bad cell phone reception, and people, as soon as they lose connection, they lose access to the app. So that's a problem. Security is difficult. So basically the way it's designed is that if you want to have more security, you have to pay for it on Shiny apps. We found a workaround to this, but at this point of development, you just need to do a little bit of more legwork to create identification screens. Shiny assumes that there's going to be a user interface. It assumes that there's going to be a UI. This is different from another situation where people productivize their model through some kind of an API. So it is not designed to productivize an API. It is designed to build a UI. And of course, it's an R-based system. So R is not the fastest language. So if you're looking for a high-performance solution, you probably want to move to something else down the road. That's essentially what I have for you. I would like to acknowledge Vector Point Research Team, Uptake, University of Illinois, National Institute of Health have funded this. Here are my conclusions. I think Shiny and similar frameworks make us data scientists more valuable. Previously we essentially could only build reports. Now we can build products. Products that not only have a model, but they enable data collection, visualization, collaboration, and prototyping. In Uptake, people have built Shiny apps that later became significant products. And I think all of that can be achieved without the traditional cost of software engineering. So this is a small revolution. Thank you very much.
Besides dogs, were there any other markers that you identified that were important in this virus or the outbreak that you called of these bugs? What kind of parameters did you load in your system?
That's right. Thanks for the great question. Yeah, I think our model uses something like 10 different variables, and it involves stuff like whether there are neighboring houses which had the infestation, whether the person had spraying done recently or not, animals, type of wall construction, the bugs like cracks in the walls, So if you know that there are cracks in the walls, there's a higher risk of bugs. The model has actually been published in emerging infectious diseases a couple of years ago. I can send you the link to it.
Well, I'll certainly look at it, but I also want to find out, you, from that data, then put those in. Were there anything that you got from those outbreak spots that were new to you, that you didn't anticipate? Was there anything that showed up in the data that you said, this isn't what we expected? So you had the certain variables, but then what was kind of the unknown unknowns? Anything?
Our focus here was to make a product. So we had a good trust in the model.
Okay.
So the model has been validated. We have a good R square. So we are pretty happy with the model. We wanted to give a tool to the inspectors, a tool that they could use to run the model and make it accessible right there in the field. Visualization and data collection right on their own devices. And that's what Shiny allows us to do. Yeah.